In this video, we're going to examine transformation of functions by looking at a function that we're not given the actual equation of the function. We could figure it out. This would be a piecewise function, but that would be a little cumbersome to try to write in function notation. So let's go back. We're going to look at a number of different examples of graphs, but let's look back at what the transformation of functions are. So we see we have this format, and this is in function notation, which means that I'm not really sure what the function is by looking right at this particular equation, because this part right here is where my function is. So it could be any function. So let me just give you an example of some functions you might be familiar with. So if I was going to rewrite this as an absolute value function, I would write it in this form. F of x is equal to a, absolute value, x minus h plus k. If I was going to write it as a quadratic function, I would write f of x is equal to a, parentheses, x minus h squared plus k. So you can see they have some similar characteristics. They all have a that's being multiplied in front of the function. X has a minus h inside the function, and we have a plus k at the end after the actual function. So each of these letters, these parameters, does something to our function. So if you remember, this is also called vertex form. So for these two in particular, this is called vertex form because it gives us our vertex, h, k. The other thing to remember is that this minus sign is part of the equation. So we have to remember that when we're looking at our h values, it's always going to be opposite of what we see inside the function. And I'll give you an example of that in a minute. So let's look at our first function. So our first function is f of x plus 3. So what I want you to remember is, first of all, f of x is just another way of saying y. So this is like our y value plus 3. So whatever I see here is going to be exactly what happens to my y. So that means I'm going to add 3 to negative 2, and I get 1. Well, that's the same as going 1, 2, 3 up. So that's my new point. So if I add 3 to 2, I get 5. Well, that's the same as going up 1, 2, 3, isn't it? So on all of these, I'm going up 3. So 2 plus 2, again, is 5. That's going up 3. 0 plus 3 is the same as 3. 1, 2, 3. So that is my transform function. It's gone up 3. So this 3 right here at the end is saying up 3. I'm going to transform all my points up 3. This next one, this big G of x, is a little tricky because notice now we're looking inside. Anytime we're looking inside those parentheses, that should be a warning of slow down, something different is happening. So if we remember from the function down beneath that we had our f of x minus h was what we had in our equation. So if we look down here, see how it's a minus h. So that's our function form, which means that, let's put it so that we have a minus h. Well, in order to make this positive 2 look like a minus h, we have to have this read f of x, and that's going to be minus, because that minus was in our original problem, our equation, minus 2. So our h is minus 2, which means we're going to move our x in the negative 2 direction. So let's go back up, and here if I were to add a negative 2 to negative 4, I move over to negative 6. So that's my new point. I moved left 2. Here, if I add negative 2 to my 0, I move left 2. Similarly, if I add negative 2 to 2, I move left 2, I get 0. And if I move 4, negative 2, I get 2. So my new function has been translated left 2, because I have to put it back into the formula, and the formula has a negative. A negative times a negative gives me my positive. Okay, so that's tricky. So anytime we're dealing inside the parentheses, we have to slow down and think a little bit. It's not exactly what we see. So let's look at another transformation. So this negative here in front of the f of x. So remember, f of x is the same thing as saying y. So what I'm doing is I'm taking my y and I'm going to make it into a negative y. So let's look at my y's here. This y is negative 2. If I multiply it by a negative, I get positive 2. So that's actually reflecting over my x-axis. Here my y is 2. If I make it negative, I'm down here at negative 2. Here my y is 2. Again, if I make it negative, I'm down here at negative 2. Here my y is 0, so it's just going to stay where it is. So if you can see, that function has reflected or flipped over my x-axis, and that's what happens when we have that negative in front of the function. Okay, so let's look at another one. So here we've combined a couple of things. So again, we have to be careful with what's happening inside our parentheses. Remember, our original equation has that negative in there when we talk about transformations. So this is going to be x minus something inside. So in order to get a positive 1, that means I have to have a negative 1, which means my points are going to move left 1 and down 2. So that's all we have to do. We're going to go left 1, down 2. Left 1, down 2. Left 1, down 2. Left 1, down 2. So you can see my function has kept its shape. It's just shifted. It's shifted down. Let me make this in green. It's shifted, left 1, down 2. So that's my shift. Okay, so let's look at some things that are a little bit different. So as long as it's on the outside of my f of x, it's very straightforward. So here, remember, this is the same as f of x is the same as y. So this would mean I'm going to take my y values and I'm going to multiply them by 1/2. I didn't put the point values on this graph. It's the same as the other one, and we can get it right off of our y-axis. So right here, my y is negative 2. If I take half of negative 2, I get negative 1. So that just goes up there. Right here, my y is 2. If I take half of 2, I get 1. And the same thing's going to hold for this point. And half of 0 is still 0. So you can see that it looks like someone's pushed down on the function, so it's compressed. So this 1/2 is a compression. It's a compression by 1/2. So let's move on to the next one. So this one here is a little tricky, and I haven't really talked about it. When we have this negative inside, that means we're really reflecting over the y-axis, and we'll see that. So we're going to take the opposite of our x values here. Okay, so we have to be careful. So my x value here is -4. So the opposite of -4 is 4. So that point translates over there. This here, my x value, remember we're talking about x value, is 0. So that's going to stay the same. Here, my x value is 2. So I'm going to have -2, which means that point is going to move over to here. Notice it's keeping my y value. My y value is not changing. And here, I have my x values at 4. So if I take -4, it comes over here. So if I were to connect the dots, you can see that it's reflected, or it's folded or swiveled over that y-axis. So this here is a reflection over the y-axis when we have that negative on the inside. Okay, so this one here I think is the most complicated of them all. It's not intuitive at all. We have this 2 on the inside, which means that we're going to take our x value and we're going to multiply our x value by 1/2. So we're multiplying our x by 1/2. Okay, and that's what I mean by it's just not intuitive. Okay, so we look at our x value. Here my x value is -4. Half of -4 is -2. Okay, and so here my x value is 0, so that's just going to stay like that. Here my x value is 2. Half of 2 is 1. Here my x value is 4, and half of 4 is 2. So this is going to come like this. So it looks like it's kind of stretched a little bit. It's been pushed in to the y as opposed to the other one that we had looked at right above it, which was kind of pushed into the x. Or in this case, this was squashed down from the y. This here was kind of pushed together around the y. So this has that sort of effect of a stretch around the y. So you have to be careful with this in particular because it does the opposite of what you think it would do. In other words, it does the inverse. So what's inside the parentheses does the inverse. So the inverse of 2 is 1/2. Because this is being multiplied, we're going to multiply our inside by 1/2. On the other example, here we were adding 2. The additive inverse is subtracting 2. So again, whatever's happening inside, since it's adding, we're going to take the additive inverse. Here, since we're multiplying, we're going to take the multiplicative inverse for that and multiply it by x. And that helps us transform our functions.